Here is a cosmic secret. Dust runs the universe. Tiny grains build stars and planets, and cool galaxies by trapping light and re-glowing it in infrared. Look up at the night sky. Stars, galaxies, maybe a planet or two. But what about the stuff you cannot see? The empty spaces hide a powerful secret: dust. They are not empty at all. These grains are often 0.001, 0.1 micrometers wide, smaller than a human hair, 70 micrometers. Yet they build stars, seed planets, and manage galactic heat. We are talking about cosmic dust. It is not lint, it is architecture. Dust lets clouds collapse into stars. Dust grows into worlds. Without dust, a bright universe would fade. With dust, it thrives. Every light you see owes a debt to dust. So, how does dust actually build a star? It is a little chemistry and a lot of gravity. Giant clouds hold mostly hydrogen and helium. Gravity pulls gas into a dense core, but compression heats the gas and fights collapse. Enter dust. On grain surfaces, two H atoms meet and form H2, releasing energy. The cloud radiates heat in infrared and cools to about 10-20 K. Cooling drops pressure. Gravity wins. A protostar forms, glowing from gravitational heat. Dust made the collapse possible. Every star seen at night, including our sun, likely began this way. New light is forged behind dust veils. When ready, the star breaks through. Once a new star is born, it is not alone. It sits inside a spinning disk of gas and dust, the protoplanetary disk. At first, grains are tiny, like smoke. Over millions of years they grow. Static makes first bonds. Grains stick into fluffy clumps. As clumps grow, gravity joins in. Fluff becomes pebbles, a key step. Pebbles sweep and accrete more material. Countless small impacts merge bodies. Pebbles grow into boulders, then planetesimals. Hundreds compete for disk material. Some shatter. Many merge. Winners carve lanes and grow fast. Over tens of millions of years, planets emerge. Rocky Earth and giant Jupiter began as dust. Every mountain, ocean, and continent came from ancient stardust. Dust also regulates galaxies like a thermostat. Hot, young stars flood space with ultraviolet light. Unchecked, that heat would stop new stars from forming. Dust absorbs UV and visible light, shielding cold clouds. Inside, gas stays cool enough to collapse. Warmed dust re-radiates energy as infrared and sub-millimeter light. Energy shifts from short to long wavelengths. In infrared, we see the warm glow of dust. This radiative cooling lets galaxies shed stellar energy. Dust shapes how a galaxy looks and evolves. Dark lanes are thick dust ribbons, not empty space. They dim starlight and manage the energy budget. Dust comes from dying stars. Carbon, silicon, oxygen, iron. Metals condense into solids and rejoin the cycle. Trace it back, and the story of the universe is the story of dust. Star death makes dust. Dust enables new stars and worlds. Around newborn stars, dust becomes planets. Iron in blood, calcium in bone, carbon in DNA, forged in stars and delivered as dust. We are assembled from stardust. Today the cycle continues across the galaxy. The cosmos is not distant, it is in us. Subscribe to our Universal Universe channel for daily cosmic adventures, and do not forget to share and like the video.